So let's get started with reviewing your fraction math skills. So today we're going to work on sharpening your fraction math skills and doing basic operations on fractions and reviewing reducing, reviewing converting whole numbers and mixed numbers into improper fractions and back and forth. So today is your skills day. All right, and several of you need to work on your own basic skills. Okay, so I'm going to be reviewing math skills beyond primary level today, and then the next time we'll apply fractions to primary, and just a few things about that. So you'll notice that your next assignment is 2-4 and 2-5. That is addition and subtraction of fractions in our textbook. So today we're going to concentrate on your math skills and reviewing basic simplifying and reducing and converting fractions. Then we're going to review addition, subtraction, multiplication, and division, the basic operations with fractions, and then we're going to cover problem areas. Okay, so let's review. Let's review with our fraction math. This is in chapter 2. This, of course, still will not be due until later, February 20th. But you need to be working on this because fractions tend to be a problem area in 4th grade, 5th grade, 6th grade, 7th grade, 8th grade, even in high school. Students have fraction phobia. They'd much rather do whole number and decimal computations. They'd much rather divide by the decimal than to divide by the fraction. When we get to the percent math in junior high, they'd much rather use decimals when actually fractions can be easier. So we have to solidify your basic fraction skills, even though you do not teach second graders how to borrow with fraction math, do you? You don't teach common denominator in primary. All you're doing in primary, we'll cover on the next lecture about understanding fractions and dividing fractions into, or dividing things into parts of a whole and understanding that. But for you, even though you're not going to teach fraction math at primary level, you've got to have good math skills in general. So with that in mind, we need to be able to manipulate fractions. Let's take a basic fraction like 2/5. That would be considered a proper fraction, right? Because the numerator is less than the denominator. But with 2/5, we have to be able to make equivalent fractions. How do you make equivalent fractions? Basic fraction manipulation to begin with here. How do I make an equivalent fraction? What do I do? Any equivalent fraction. What do I do? If I want to raise this up to a higher terms, what do? Multiply what? Pick a number. I have to multiply the numerator and the denominator by the same number. It doesn't matter what that number is. If I multiply the numerator by 3, I have to multiply the denominator by 3. That's an equivalent fraction. This is said to be in lowest terms, and this is simply in higher terms. This is what I do when I need to find a common denominator so that I could add or subtract fractions or mixed numbers. So the first thing we have to understand is equivalent fractions. I can keep going. I can multiply 2 by 15. And so then I multiply 5 by 15. It doesn't matter. As long as I multiply and divide the numerator and the denominator by the same quantity, the fraction will be equivalent. So here I'm forming equivalent fractions by multiplying the numerator and denominator by the same value. All right, then going this way, equal signs are always two ways. I have to be able to raise the term of my fraction to a higher denominator or reduce my fraction down to the lowest terms. So I need to be able to form equivalent fractions, and I need to be able to reduce my fraction. Reducing, of course, is done through division. So if I want to reduce this to lowest terms, I am going to divide by the greatest common factor. And at this level, we can just use our divisibility rules, or we can use our times tables, and we keep dividing down until the numerator and denominator are prime to each other, or relatively prime. So can you form equivalent fractions? Do you understand what that means? And can you then reduce? We need to be able to reduce fractions, even ones that start getting a little big, like 72 over 96. What's the greatest common factor between 72 and 96? 12. Yes. Because, oh, not 12. 24. 12 gives you your times tables, right? And that's fine. You can reduce in more than one stage. 6 times 12 is 72. 8 times 12 is 96. But that's not in lowest terms, so I keep dividing. This will go down one more time. So I keep dividing until I have my fraction in lowest terms. So the greatest common factor here is not 12, it would be 24. See how we have an extra 2 factor? Okay, now in the intermediate class we spent a lot of time on prime factorization and being able to reduce larger numbers. Another way that you can do this by times tables and in multiple steps, that's how fourth graders do it. But as you get older, you could also do this by prime factoring. What are the prime factors of 72? 72, remember, is a composite number. That means it's made up of a group of prime factors. Okay? Repeated prime factors in the case of 72. So when I think 72, the first thing I usually think of is 8 times 9. It could be 6 times 12, it really doesn't matter. And then 8 I know is repeated 2s. 2 times 2 times 2. And 9 I know is repeated 3s. So there's 72. 96, I'm going to think 8 times 12. Well, there's my 8. And 12 is 2 times, or 2 times 6, or 4 times 3. So there's 96. It's equal to 8, see the 8, times 12. Here's the 12. 12 is 4 times 3. So then, left on the top is my 3, and on the bottom is 2 times 2, my 4. So reducing can always be done through prime factorization and cancellation of common terms. And you see I canceled 1, 2, 3 2's, which is 8, and a 3. I canceled 24. 24 is the greatest common factor. So to reduce, we have to divide both the numerator and the denominator by the greatest common factor. In this case, it's going to be 15 because we did that earlier on purpose by 15. But if we take 30 70ths, or 30 75ths, 30 is 2 times 15, isn't it? Right? But 15 is not prime. I'd have to write it as, there's 15. See it? 75 is 3 times 25. That's the first thing I would think of. It's 3 times 25, which is 2 5s. So I can see here's my greatest common factor, and when I cancel my greatest common factor, that's how I get my lowest term, 2 5ths, back to my 2 5ths. Okay, so when you have to reduce, sometimes I'm going to give you larger numbers, and it'll take you 10 years to go through it this way and keep dividing in random. There doesn't have to be anything random. You can always prime factor and cancel individual factors, and it actually will take you less time, and it's certainly more accurate than you doing all these little multiplication, or rather division problems all over your page. So can you form equivalent fractions and reduce no matter how big the numbers get? Okay, so reducing is one of the first math skills that you need to remember. And then we're still just at the beginning here, remembering how to manipulate our fractions. And we have to remember our terminology. So on this example that I just erased, this is a proper fraction, right? Because the numerator is less than the denominator. And when I formed 6/15, I formed an equivalent fraction. 2 2/5. So I have to have the same terminology, and now you have to have the same terminology that I'm using. It's the law of language. So proper fraction, and then equivalent fractions. If you tell your fourth grader to form an equivalent fraction, what are you going to get? Probably a blank page and a dumb look. So what do you have to do? Define your terms. Even sometimes the seventh graders are a little shaky on what do I mean by equivalent fractions. Okay, so I have to use the terminology here. Now the next step is for me to take a mixed number and rearrange it into its improper fraction equivalent. Improper fraction can be any fraction where the numerator is greater than or even equal to the denominator. If the numerator is greater than or even if it's equal to the denominator, it is improper. And so I have to remember how to do this. We can make a little diagram. 8 times 1 plus 3. 8 times 1 is 8 plus 3 is 11. And I'm not changing the denomination, I am just changing the form. So 1 3/8 is a mixed number because it has a whole number and a fraction, and that can be rearranged into an improper fraction. Improper fractions, numerator greater than denominator. Okay, so all these little details you have to dredge up from your memory banks from arithmetic, maybe 8th grade, okay? Maybe longer ago than that. So make sure you yourself have your fraction skills intact and you remember the terminology and you remember some of the little details because these are going to be used. We have to form equivalent fractions when we add or subtract, don't we? We have to be able to reduce an answer when we're finished. Then when we're multiplying and dividing, we have to be able to change it to the improper fraction. But sometimes when we're done adding, we will get an improper fraction and we have to go both ways. So here's how I go from mixed to improper. And then I have to go backwards. So what does this bar mean? If I'm going the reverse, I have to understand what a fraction is. A fraction is a division problem, isn't it? And so I always divide by the denominator because that fraction bar, when it's read as a division problem, is 11 divided by 8. So I do what it tells me to do. 11 divided by 8 is 1. Remainder goes back as a fraction over my denomination. I stay in the same denomination. I stay in the form of 8s. So it's important that you remember this, and this is can be a big problem, is because later on they're going to just always divide by the smaller number. No, you always divide by the denominator. because a few weeks down the road, if we start doing decimals, we have to know which way to divide. All right, so make sure you're up to par with your terminology and just your manipulation of fractions as needed. And that brings us to basic operations. On fractions now. What are the 4 basic operations of I almost said the first one. What are the 4 basic operations of arithmetic? What are they? Yes?
Add, subtract, multiply, divide.
Yep, so we're going to put these 2 together, and then we're going to put these 2 together. So arithmetic has 4 basic operations. Addition and subtraction, which are, how are they different? They're inverse of each other. How are multiplication and division different? They're inverse. But they do go together. Addition goes with subtraction. Multiplication goes with division. They are different because they're inverse of each other, but they are the same. As a matter of fact, in algebra, algebra has only 3 basic operations. Arithmetic is what we commonly call math, but math is actually anything involving numbers and computation. So, what are the basic operations of algebra? There's only 3. And this does relate to some fraction math. Addition, multiplication, and exponents, or raising to a power. What's missing? What's missing?
Division and subtraction.
Division and subtraction. Well, in algebra, we do not need subtraction. Doesn't mean we don't do it. Does anybody know why we don't really need subtraction in algebra class? Yes?
Because you're just going to be adding it to the other side using addition?
Adding what?
The term?
Adding what? Nope.
The inverse. No.
Not the inverse, the opposite. What's the opposite of 2?
-2.
Yes, we have negative numbers in algebra, don't we? So we add the opposite. Which is literally the opposite side of 0. Here's 3. And there's -3. We have negative numbers in algebra. We can slowly and actually, we don't need subtraction. We change the sign and add, remember? So this comes back to, I noticed on your quizzes, you couldn't really tell me how are addition and subtraction alike? How are they different? How are multiplication and division alike? How are they different? They're alike in that eventually we won't even distinguish them, will we? And if you remember from junior high, remember when you had to learn the properties of addition? You had to learn the commutative property of addition, the associative property of addition, the inverse property of addition, the identity property of addition. Remember those? Remember getting them all mixed up? And remember not being able to remember the name? Well, are there any subtraction properties? No, because technically subtraction is not really its own operation except in arithmetic. All right, division is missing because it's not really distinct from multiplication in algebra class. And here's where fraction math comes in. Do we divide fractions? Do you divide fractions in math? What do you do? What do you do when you have to divide? What do you do? You invert the divisor and multiply. That's called the reciprocal, not the opposite. Opposite is sign. So we don't need division anymore because we are going to multiply by the reciprocal. So multiplication and division are alike. They go together. Eventually, division is replaced by multiplication by the reciprocal. Just like in addition subtraction, eventually subtraction will be replaced by negative numbers, adding the opposite. Okay? So addition and subtraction are opposites. Multiplication is the reciprocal, multiplying by the reciprocal. And that's how fraction division is done. Exponents. That's where we have squaring and square rooting, or cubing and cube rooting. And so basically these eventually will no longer be distinguished and so forth. But these are alike because the law of addition applies to both. You can only add like quantities, you can only subtract like quantities. But we're also different in commutative, associative. All of those specific addition properties do not apply to subtraction, do they? Only to addition. Okay? Subtraction is not commutative. We can't reverse the numbers. In fact, the numbers are distinct. We have minuend and subtrahend with subtraction. With addition, we just call them whatever add-in. Okay? The one last thing before we leave this. Okay, you're teaching primary. What is multiplication? You know what? I think I'll draw the arrow the other way. What is multiplication? It is repeated addition. So if I have 3 plus 3 plus 3 plus 3, it's much easier to say, oh no, that's just 3 times 4. What are exponents? In particular, what is an exponent of 2? What is exponents? Okay, come on, let's think. If multiplication is repeated addition, it's a repeated multiplication. It's not 3 times 4, it's 4 factors of 3. This is 3 to the 4th power, isn't it? So basically there's only 3 operations: addition, multiplication, exponents. What's the relationship between rooting and squaring? They're inverse. What's the relationship between cubing and cube rooting? They're inverse. Just as much as addition and subtraction are inverse of each other, squaring and square rooting, raising to a power and rooting are inverse. Okay, so keep in mind what we're doing here. With addition and subtraction, the law of addition applies. So with both addition and subtraction, the hard thing is to find the common denominator. Then when we get to multiplication and division, there is no law of addition. We don't have to worry about multiplying or then dividing likes. And then we do have a commutative property and associative, but that, again, those do not apply to division. Can you flip around the divisor and the dividend? In other words, is this the same? So division is not commutative, and division is not associative. But they are inverse of each other. So they are alike, but they're also different. And eventually, we don't even distinguish them, do we? Okay? So let's do addition and subtraction of fractions. Addition and subtraction both require, or both are subject to, they both require the common denominator because they're both subject to the law of likes. Right? So, on both of them, the most important technique is finding the least common denominator. But before we even go there, don't forget what we're really doing. 3/8 plus 2/8 are 5/8. Keep in mind what the denominator is. It's the denomination of the fraction. So this is the same as 3 inches plus 2 inches equals 5 inches. So the 1/8 is like a unit. This is in eighths, just like this is in inches. So we only add the numbers, right? Remember? We only add the numbers. That's why this thing up here on top is called the what? Top number. Numerator. Because it's literally the number of the fraction, just like this 3 is the number of the unit. And the denominator is literally the denomination or unit of the fraction. So that's important. We'll come back to that and stress it when we're talking about teaching just a little tiny bit of fractions to third graders and maybe a smidge to second graders. So for you, your basic math skills are going to involve finding the least common denominator, which is the least common multiple between the two of them. So this is the easiest one of all because 3 and 5 share no common factors. They're relatively prime. This is denominator scenario number 1. The first situation, and the easiest one, is least common multiple is their product. Because they have no common factors, so the smallest multiple that contains the factors of both is simply the product. All right, and then remember to form the correct equivalent fraction. We have to adjust our numerator to the new denomination. We've got to form the correct equivalent. This is only equivalent if we multiply by 5. This is only equivalent if we multiply by 3. So then I get an improper fraction when I add my numbers. So we have to be able to quickly and accurately and actually mentally convert that. You should be able to immediately see that 15 only goes in there once, and then you can see the subtraction. What's 22 minus 15? 7. So fraction addition should be easy for you at this level and at this type of, at that type of denominator. Denominator scenario number 2. What happens if I have 5/6 plus 7/12? Denominator automatically is what? 12. Why? Because 6 goes into 12, but that's not how we say it. 6 is a what? Factor of 12, right? 6 is a factor of 12. What do we say about 12? 12 is a multiple of 6. Many students, looks like all of you included, do not use the word factor and multiple. And so then when I ask you for the least common multiple, it throws you off. What is a multiple? Here's the multiples of 6. Oops, 24, 30, etc. Here's the multiples of 12. Far enough, right? Those are multiples. So the least common denominator is literally the least common multiple between the two. So if you're stuck and you can't think of the common denominator, you can write out multiples, can't you? But you should be able to, in denominator scenario number 2, 6 goes into 12, so we call it a factor of 12. And then 12 times, or 6 times 2 is 12, so 12 is a multiple of 6. 6 is a factor of 12. All right? Must have had teachers who never used multiple and factor. Right? So that means when you're the teacher, you use multiple and factor. All right, so we need to be able to find common denominators. This is easy. This is 4th grade. You're not in 4th grade, so you have to be able to do this. Denominator scenario number 3. Let's up the denominators out of our times tables. What's the common denominator here? It is not 32. It's going to be what? 48. How can you figure that out? You can start thinking through the multiples of 16. 16 times 1, 16 times 2, 16 times 3, until you know your 12 times tables, you will recognize that as being also a multiple of 12. So we will go with 48. And here, let me show you again the, I'm going to use the word beauty, even though I know you guys don't think it's true. Math is not, beauty doesn't belong in math class, does it? But the beauty of composite numbers is the fact that I can play all kinds of games with this. 12 times 16, I'm not going to use 12 times 16, am I? In fact, here's the multiples of 12. And you can see, yeah, I am going to use 48, but you can always find the least common multiple by taking the product and dividing it by the greatest common factor. Oh no, I'm throwing those words around in the same sentence. Least common multiple, greatest common factor. What's the greatest common factor between 12 and 16? Factor, common factor. Let's just say common factor. Let's drop the adjective. What's the common factor between 12 and 16? 4, right? Right? Because 8 doesn't work. What's the least common multiple? Or what's the common multiple? 48. So my greatest common factor is going to be 4. So I'm going to use 48. See that? 3 times 16. Or I can put things in prime factored form. Here's 12. Do you see the 12 in the primes? Do you see it? 16 is 8 times 2. 16 has no 3's in it, does it? But do you see the greatest common factor between the two is 4, isn't it? So then the least common multiple is when I arrange the smallest composite that contains the factors of each. There it is. There's 48. See how it literally contains the factors of 8? And it literally contains the factors of 16, not 8, and the factors of 12. So there's all kinds of different ways you can come up with it. You don't want to be just trying random numbers, popping out the 32 and hoping it works. 32 doesn't work. Or going all the way up to 72 or something like that. Wait a minute, 72 is not a multiple of 16. Because 16 times 5 is 80. So 72 is not going to work. All right, so we don't have to try random math. We can figure it out. And this might be the easiest way to figure it out. The point is, you've got to figure out that you need the 48. And then you have to adjust these accurately. This is times 4, this is times 3. So then I'm going to get 41 48. I have to form equivalent fractions using 3, and then equivalent fractions using 4. Right? Can you find common denominators? On your homework, you're going to have to find common denominators quickly and accurately. On the fraction quiz, coming up at the end of the month also, you'll have to be able to do harder denominators than 4 and 8 and 6 and 12 and 3 and 5. So with common denominators, we've got to be able to find the least common denominator. When we're doing addition, the next thing that comes up with addition is converting. We don't exactly carry with fractions. We have to convert improper fractions. That replaces the carrying. So if you got a piece of paper, let's do a few problems. Let's try this one. And we'll go with adding mixed numbers. Can you quickly and accurately add mixed numbers no matter what denomination we're using? We've got ninths, we've got eighths, we got fourths. Common denominator. First of all, I don't worry about the 4. Why not? It's in the 8. So I'm going to concentrate on 8 and 9. What's the relationship between 8 and 9? 72, because they have there's no commonality. 8 is 2, 2, 2, 2. 9 is 3 times 3. They have no common factors. They are prime to each other. So I automatically go to 72. And procedural-wise, I would bring the 5 over, and the 4 over, and the 3 over, the whole number's over, and I'm going to go to 72. Uh-oh. How many times is 4 going to 72? Am I going to do this? Not me. Are you? I don't have to. Think, 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 think. How many times does 8 go into 72? How many? 9. So how many times does 4 need? 18. I don't do that. We're college students. We don't do this. We do use your mind. Think it through. If 8 goes into 72 9 times, and it does, for 4 to go into 72, I need double the 9, don't I? Because 8 is double the 4. I'm not going to do the division problem. I'm just going to go right to 18. I can let the work on the 4 follow the work on the 8. Just double it. Right? So, listen. What is 3 times 9? So what's 3 times 18? Double it. 54. Right? 27. So look, that's the beauty of multiplication and numbers. We don't have to do all this math. So, if 8 goes into 72 9 times, 4 has to go into 72 18 times, right? You can see that. Now apply it here. If 3 times 9, if 3 times 9, let me put it in the right place. If 3 times 9 is 27, what is 3 times 18? 54. Double, right? So this has to be double. I don't do any scrap paper math. You don't have to either. And you don't have to make dumb mistakes on your scrap paper math if you just start thinking. I know it's painful. That's what I always say to 7th graders. I know it's painful, but we've got to think this through. Do you see how I did that? Do you see that? That's not that hard. This is some of the things that teachers and parents of homeschoolers need to instill in their children. This is called mental math. You know, I can't really in my head do 3 times 18 that quickly, but I can easily do 3 times 9 double to 20, or double to 54. And I can double 54 or 27 really easy because I can double 25 to 50, right? And then that's 2 more, so it has to go to 4, so it's 54. That's called mental math. It's called using your brain without having to rely on your fingers to show your brain so much. Okay? 9 into 72, of course, is 8. 8 times 4 is 32. Now I'm going to do all my addition at once, or I could do it separately. But I'm going to do the numbers here, and I get 9. 2 and 3 is 5, plus 4 is 9. 11, and 3 is 14. Okay? So, I'm also going to go ahead and do this. This is 12, and I have to carry, don't I? Some of you guys are frowning. Did I add wrong? Okay, you're scaring me. All right, so how many times does 72 go into 149? Twice. 144. So I have to carry a 2 here, so I'm going to have 14. And then 144 leaves 5, 70 seconds. You could, if you wanted, you could convert this and then carry the 2 up to here. That can be kind of dangerous. If you put off the adding, you're going to forget to add. It's probably better to do all of the addition at once than adjust the answer accordingly, carrying the 2 to the 12 here instead of up there. Okay? Can you do college level addition of fractions? And the key there is common denominator. And equivalent fractions have to be correct. Often the equivalent fraction is not correct because the numerator's been multiplied wrong or something. Subtraction. Subtraction comes after addition, always, and subtraction follows the common denominator. So for us, what we have to worry about is borrowing. Subtraction always has to, time during subtraction always has to address borrowing. So we're going to start with basic borrowing. Let's say I have 4 and 2/3 minus 2 and 7/8. Common denominator between 3 and 8 is 24. Why? They're prime. 8 is 8, 3 is 3. So I'm going to go with then 4 minus 2. 8 times 2 is 16, 21. 8 times 3, then 3 times 7 is 21. So I have to borrow. So we have to borrow in terms of 24. Once we have the idea of the whole number being 24 24ths, I can now combine my minuend into 3 and 40 24ths minus 2 and 21 24ths. Don't forget the principle of borrowing. I am not going to borrow and make this an 11 so that I can subtract from it, am I? I have to borrow 1 in the same denomination as my fraction is. I'm borrowing 24 24ths, And another problem is some students will want to do 24 minus 21, but that's not the case. I have to rewrite my minuend with its borrowed fraction. So I had 16/24. I added 24 more 24s that I borrowed from my 4. Here's my finalized subtraction problem. I can do 40 minus 21. So I can do that and get my 19/24, 1 and 19/24. So make sure you remember the logistics of how to borrow. I get my common denominator and see what denomination my problem's going to be in and see what I need to borrow. Don't forget to take it from the 3. Don't forget to completely redo your minuend so you can see what's going on with your borrowing. So you can see what's actually going to be subtracted. And every book, every curriculum, every test, every quiz throws the curveball of what happens when there is no fraction in the minuend. Autopilot does what? Autopilot brings the 3/8 down. Autopilot doesn't work, does it? Okay, so what I have to do is make sure that I never ever bring down a subtrahend. I'm going to borrow 1 from the 5 and I have to subtract. Never bring down subtrahends. They have to be, minuend has to be borrowed, and then I can get this. If you take a look at this done on autopilot, this is too big. Is that going to add back to 5? No. That should look bad. Is this going to add back to 5? Yes. Subtraction can always be checked by taking a look at it again. Does it add back? Does the difference plus the subtrahend add back to the minuend? So don't forget how to borrow. Then we are going to also be reviewing multiplication and division, which most students prefer because addition and subtraction becomes tedious because of common denominator. So we can boil down, we have no law of likes, we can boil down our fraction multiplication into this idea, which I've showed you before. Don't forget. With fractions and mixed numbers and whole numbers, and with both division and multiplication, the only way we can do the operation is a fraction times a fraction only. So if I have a fraction times a whole number, if I have a fraction times a whole number, how do I do it? I rewrite it as fraction times fraction, right? I can't multiply whole numbers. Well, at your stage, you probably automatically picture this in your mind, right? We put the 5 as a whole number, but we automatically should be doing this. Oh yeah, that's going to be 5 over 1, even if we don't rewrite it. What if I have a mixed number times a fraction? Mixed number times a fraction follows the same rule. It's always converted to fraction times fraction. Fraction times fraction. That's the rule no matter what I'm doing on section 2.6 and 2.7. I convert everything into the basic form, fraction times fraction, because I'm always going to multiply numerator times numerator and denominator times denominator to get my new product. So I convert. Before I multiply, I convert into the form of fraction times fraction. So whether it's a mixed number or a whole number, it has to be rewritten as an improper fraction. So improper fraction times improper fraction. Okay, so if I have a whole number times a mixed number, does not matter. It's going to go into, we got here 21/8, 7/1. Oh, too bad it's not division. I could flip it over and cancel. So fraction times fraction. That's the only way that I can do multiplication and also division in the fraction chapter. Now let's talk about canceling for a minute. Canceling goes back, cross-canceling goes back to the beauty of multiplication. Okay? So if I have, let's say I have, we'll make up one that has lots of canceling. Let's say I have 32/5 times, we'll do 35/8. Well, let's do 35/18. We'll do that instead. That's a little, I had a little too much canceling going on there. I don't have to do the multiplication here. Here's one way you can think of it. I'm going to be multiplying the numerators times the numerators and the denominators times the denominators. I can get rid of that 5, can't I? I have a 9 times 2 here. I have a 2 times 16. I can get rid of a 2. This is going to lower it a little bit, at least. Now I only have to do 16 times 7. What's 16 times 7? 100 and what? 7 times 6 is 42, 112. Then do I have to worry about further reducing? I don't have to worry about further reducing. I can reduce as I go. I can do 2 out of 18, 2 out of 32, 5 out of 5, 5 out of 35. Or I can do it in prime factored form. 32 is 16 times another 2. 5 is 5. 35 is 5 times 7. 18 is 2 times 9. So I can see there's the 5 and there's a 2. That does leave me with 16 times 7 and 9. So cross-canceling is just a way. What would be the point of multiplying it out and dividing it back? Multiplication and division are the same operation in algebra, aren't they? So that means they're done simultaneously. So you don't have to do, oh, what in the world, 32 times 35? I don't want to do that. Do you? And that's where I'm going to make a mistake. 18 times 5 is not so bad. So cross-canceling works because multiplication and division are the same operation. They can be done simultaneously. One can be done kind of I did the division first. Isn't that what I'm doing? When I cross-cancel, I'm doing the division first. And then, of course, division, as we mentioned at the beginning of class, division doesn't qualify as a separate operation. So what do? When I divide fractions, I don't. I invert only the divisor. Don't invert them both. I invert the divisor and multiply. So if I have 2/3 divided by 5/6, I automatically have to go back to what I said earlier. Only fraction times fraction, no division. So I do 2/3 times its reciprocal, 6/5. Then cancellation can be done. No cancellation of division. Okay, so everything in section 6.26 and section 2.7 is all going to boils down to fraction times fraction. And of course, we're always going to use, when it's a division problem, the reciprocal. So if I have 1 5/8 divided by, let's see, we'll do 2 2/3. This has to go to 8 5 13 eighths, and this has to go to 8/3, right? But then I'm going to automatically go to 13/8 times the reciprocal. No cancellation. Get it in form before. This, sorry, is 39/64. No cancellation prior to. Cancellation is a multiplication technique, not a division technique. All right, so we reviewed how to reduce and manipulating the fraction back and forth between mixed number, improper, and the 4 basic operations. So I want you to do those sections in chapter 2 to get your own math skills polished up a bit more. All right, we'll see you on Friday.